new material before the next exam, but we are going to spend 3 classes on it, so that is through next Tuesday, and then that means next Thursday's, the homework would be due for that, and will be a review day. And so 2 weeks from today will be your next exam. I want to say October 29th. Right? Okay, so this is the last new material in this packet, and it is on interval estimation. So up until now we've done what's called point estimates, right? Point estimation. Point estimation, you give me one number to represent another. I say, what do you think the population mean is? You would give me the sample mean and say, well, that's my best guess. You give me 1 point to represent another. But in this, when we know that it wasn't perfect, right? If you did a sample, hopefully it's close enough, but it wasn't perfect. So in this chapter, instead of giving me one number, you're going to give me a range. You're going to say, I think the population mean is between here and here. You're going to give me an interval that you are, and you'll decide how confident you want to be. We usually use 90% confident, 95, or 99. And so usually we want to be perfect. We want to be really sure, right? But if I want to be sure, really, really sure, I either have to take a very, very large sample, right? If I take a very large sample, it costs me money. It takes me time, right? It takes me longer to do all the calculations and figure it all out. And so sometimes you don't need to be really, really sure. Okay, so you have to decide if it's good enough to be 90% confident, 95% confident, or do you want to be 99% confident? And so maybe you'd need to, well, either if you want to be really confident, you have to balance a couple things. You don't have to take a bigger sample. For example, let's say our average sales, we take a sample mean, and we got X bar was $50,000. And I want to tell my boss this range. I'm like, well, I'm 95% sure it's between here and here. Okay. Everything else remaining equal. The more confident I want to be, will I make this wider or will I make this narrower? Huh? Wider. Everything, right? If I said, I don't know how old Colton is. No idea. If I want to be 100% sure, I would say he's somewhere between 2 and 98. Am I right?
Yes.
I'm right. It's why I'm really confident. If I make my net really wide, I'm bound to catch the right answer. And the narrower I make it, the less confident I become. If you tell me to guess within a year, I am probably 2% confident that I'm right. Right? So everything else remaining equal, that's going to be a new term that it's going to be used a lot. Okay? Everything else remaining equal. The more confident I want to be, the wider my confidence interval will have to be.
How does that affect accuracy then?
So it's not very useful, right? So if I said to my boss, oh, I'm 95% sure that our average sales are between $1 and $1 million. That's not very useful.
Mm-hmm.
So when I balance, that's called my confidence level, my 90%. How confident I am, I have to balance that with my sample size. So there is another way I can become, there's 2 ways I can become more confident. One is just to make it wider, right? But I can become more confident by making my sample size bigger. And so you'll see that as we go through with the formula. That if I take a bigger sample, I can make it narrower. I can also make it narrower by becoming less confident. I say, well, 12% sure our average sales are between 40 and 60,000. But your boss doesn't really want you to be 12% sure. And that's not very useful to be a lack of confidence. So we're always balancing our confidence and because we don't want this to be too wide, right? We don't want it so wide that it's useless. but we don't wanna be so narrow that our percentage of confidence is so low. So you'll see as we go through, but this is a term we're gonna use, everything else remaining equal. The more confident, everything else staying the same, if you want me to be more confident, I'm just gonna make it wider, because I'm more likely to catch the right answer, right? If I said he's between 2 and 100, well, that's not very useful, but I'm right. But if I said he's between 23 and 25, I might not be right. He's not.
Turned 27 yesterday.
Oh, happy birthday. So see, but it's like the narrower you make it, the less confident you become. So we're going to do an interval estimate in chapter 8. So point estimate is when you use one number to represent another. But an interval estimate, you're going to give me two numbers between here and here, and that's what you're going to do. Okay. So every interval estimate, we're going to start with means, and then we're going to move on to proportions. Okay. We're going to start with means today, where we're allowed to use z-scores. Next class, you'll be so excited to come back. We're going to do means when you cannot use a z-score. Every single interval, okay, is a sample statistic. Today it's going to be x bar, right? Plus and minus what is called a margin of error. Okay? And the margin of error is the part that's comprised, it has two factors that play into how big your margin of error is. One is based on your confidence level, how confident you want to be, right? And today, that's going to be based using a z-score. Next class, spoiler alert, do a t-score, just saying. But for today, it's going to be a z-score. Okay, and then this is going to be based on your standard error. And this is standard deviation divided by square root of n. And what's this thing called? Finite correction factor. When do I get to use it? When what's 5%?
Population.
The sample more than 5% of the population. Okay, use if you're set, this is a reward, right? Not everybody gets to use it. If you take a little sample, you don't get to use it. Okay, so this is still back from tying into chapter 7. This is your standard error. This is going to be our confidence level, and this is how we come up with it. So how wide's a bell? 6 standard deviations. How wide is a confidence interval? Two margin of errors, right? Because I'm taking the sample statistic x bar and I'm subtracting the margin of error to get this number, and I'm adding the margin of error to get this number. So every confidence interval is 2 margin of errors wide. Every confidence interval is 2 margin of errors wide, and your margin of error is going to be made up of partly your standard deviation, but also your confidence level. So we're going to have an interval. If you're asked to calculate a confidence interval, you're going to do all the work. If you are just asked for the margin of error, you're going to just do this part right here. If you're asked for the standard error, you just do this part here, right? This part is the standard error. This together will be the margin of error. And the confidence interval will be this number plus and minus the margin of error. Got it? Okay, so how confident you want to be. So you have to decide. Okay? The person doing numbers gets to pick. Do I want to be 90, 95, or 99? Or any other number. You can do 87, 93%, right? You can do whatever you want. So if I say to you, I want to be 90, this is the same way of, this is many ways of saying the same thing, okay? If I'm 95% confident, okay, that is the same as saying 1 minus 95% by 0.05 level of significance. It's the same thing, significance, okay? 95% confident, a 0.05 level of significance. Alpha is the symbol for the level of significance. Alpha is 0.05. This is all different ways of saying the same thing. Another way is we'll say it's a 0.95 confidence coefficient. Okay. Just know that you would never be told to be 5% confident, would you? I mean, who the heck would want to know? I'm 5% sure I'm right? So if it's 95% confident, 0.95 confidence coefficient, 0.05 level of significance, or alpha's 0.05, they're all 4 ways of saying the exact same thing. They want to be 95% sure you're right. Okay? So they're just different ways, and each question has different ways as you do your homework. Some will give you the level of significance, and some will give you the confidence level. But they're all the same thing. All right? Okay, so as I said, everything, this is for the interval estimate for a population mean. We have a sample mean. We need to find the interval that we think the population mean falls. Okay? So I have the sample mean. So I'm going to take the sample mean, I'm going to add and subtract the margin of error. So as I said, today we're going to do the z-score, and next we're going to do a t-score. So you still have to remember those 3 rules about when you're allowed to use a z-score. Do you remember what they are? When are we allowed to assume a normal distribution and use the z-scores? Number 1, the underlying population is bell-shaped and sigma is given. What was number 2? See how nerdy you sound? And it's a compliment to be nerdy about it. Sigma's given. What was number 3? N is more than 100. Okay, so before we start using z-scores here, we're going to have to prove it. Okay, still the proofs like we did in chapter 7. Same proofs. Proofs don't change. There's not new ones to learn. Okay, but if we can prove one of these 3 things, we can use a z-score to represent our confidence level. Okay? All right, so we're trying to, if this is the sample mean here, right, we're trying to find, we want to be, let's say, 95% confident. We're trying to find this number here and this number here, so that this bit in the middle here is 95%, right? So if I have proved, let's say I've got my little proof over here that it's bell-shaped, and then I draw my bell, here's my mean here, and I want to find one of these 2 numbers here such that this here is 95%. Okay? So this is really tying back to chapter 7, because before we can find these numbers, we have to find, what are these down here? The z-scores, right? So the difference, so you don't go look up in your table 95%. Why not? Because that's not going to give me this z-score. Because the z-score, to find the z-score, I need to know the area all the way to the left, right? And this is 95% only to here. So if this is 95, what's this little bit down here? 2.5, right? Because this bit up here is 2.5. Do you agree? So if I want to find this z-score, what area do I look up? 97.5. This 95 plus the 2.5. So if you look up in your tables, what z-score, will this be positive or negative? Okay, start on the positive table. Yes. This is one you're going to know off the top of your head very soon. Okay, so without looking, what do you think this one is? Because these are mirror images, right? If this is 2.5, this is a reflection of the other side. But you can check. If you go look up 0.025, right, you can look that up and it'll be negative 1.96. Yeah.
I feel like it'd be easier just to look up where 0.025 is and then
Yeah.
just put the sign.
You can do that. So when you're looking for 95% though, the key is don't look up 95%. Because what you're gonna see is for this formula, it's gonna have the z, and down here it says alpha divided by 2. And so that's exactly what you were saying, Grant. What's alpha? Your level of significance. That is your chance of being wrong. If you want to be 95% sure you're right, that means that 5% of the time you're wrong. That's what your level of significance or your alpha represents, is your chance of being wrong. So this says it's the z-score for alpha divided by 2. So if you're 95% confident, your alpha is 5%. 5% divided by 2 is 0.025. So you can go into your z tables and look up your alpha divided by 2, and because this is going to be plus and minus anyway, so you could look up the minus side. So you would, here it would be the 1.96, right? So you're going to see that the margin of error is going to have this z, it's got this little sub alpha over 2, and that's what it means, and that's what you can see is drawn here on the ends. Okay, so here's a alpha divided by 2, and here's alpha divided by 2, okay? Okay, so this is what the confidence interval formula looks like that you will see on your formula sheets. It's got the sample mean plus and minus the z for alpha divided by 2, and then what's this part here called altogether, these two parts? What is it? No, this is the finite, but this times this. Standard error. Okay, this is the standard error just like you saw in chapter 7. Okay, you've got to decide whether or not you can use a z-score based on these 3 rules over here. But usually the one you see, it's n is greater than or equal to 30 and sigma is given. Okay, if you are asked to calculate the margin of error, you want everything past the plus and minus. Right, that's the margin of error. The z alpha over 2 times the standard error. Okay. So remember, you get to decide, right, when you get, if you get to use this finite correction factor. And the rule is you use it when n is greater than, little n is greater than 5% of big N. Remember that from chapter 7? So here's a question. Discount Sounds has 260 retail outlets throughout the United States. The firm is evaluating a potential location for a new outlet based in part on the mean annual income of the individuals in the marketing area of the new location. A sample size, n is 36, was taken. The sample mean income is $31,100. The population is not believed to be highly skewed. The population standard deviation is $4,500, and the confidence coefficient to be used is 0.95. Okay, first I want you to take a minute and write down all the information that you have been given with the appropriate symbols. Big N is 260.
X bar is 31,000.
X bar is is what?
31,000.
What's that? 1,100.
Sigma is 4,500.
Alpha is 0.05.
Ooh, we weren't given that, but Ryan arrived at that. Alpha is 0.05. We were told 95% confidence coefficient, so very good. Alpha is 0.05. Anything else? Is that it? Does anyone see any mistakes?
Is it saying that, like, for big N, isn't it like doing it for, like, its employees, not for the stores?
Not employees, but you're on the right
Surrounding
track.
population.
Right, so this is when someone said this, I started to put a dollar sign and then I erased it because none of you told me any units. And if you, in your first exam on one question, I kept writing a lot of dollar signs and a B, right? Because you didn't put dollars and billions. And so this is where if you'd told me the units, you might have caught yourself because there are 260 retail outlets. Okay, that would only be big N if they sampled 36 retail outlets. If they went to 36 stores and said, what's your sales or whatever, then big N would be 260. But they went to a town and they asked 36 people in the new location, right? Or in the potential location. So what would big N have to be?
It's unknown.
It would have been, but what would it have been? It would have been the size of the town. Right, or adults in the town, right? It would be the population of the town, not the stores. So in English, that 260 would be called a red herring, right?
So wouldn't it be the population of the entire town, not just the population of the employees of the 260?
These aren't employees. I think it says that they were looking at the mean annual income of the individuals in the new location.
Gotcha. Okay.
So let's say Josh, he makes 100,000. Could he live in this town?
Yeah.
Sure. It could be that, 2/3 of the town are unemployed and make nothing, and 1/3 of the town makes 100,000. That would make their average like 33,000 for the whole population, right? So, yeah, that's the average is 31,100. Doesn't mean that Josh doesn't own the palace on the hill. That's, because he makes $100,000 a year or whatever. Okay, so be careful with your symbols and numbers. So it helps if you had put, right, symbols like units by all of these things to keep yourself on track. So you don't get distracted by these red herrings because sometimes you're given more information than you need. And in English, they call it a red herring is like to throw you off the track. Like if you read a Agatha Christie, a mystery novel, well, you don't want to know from the very beginning, Colton was the one who killed you, right? You want to say, oh, it could be this person, there's other little clues that like detracts you so you don't know who done it at the end. And so that's what this is, a red herring. It's something to kind of try and knock you off the path, the right path. So don't let it do that to you by keeping it written like this. Okay, so they're going to ask us to do a confidence interval. Okay, so in your formula sheets that's on the front of your packet, may I borrow that? You're going to see that in chapter 8, there are 3 different confidence intervals. The first one says confidence interval for mu, that's a population mean, and so does the second one. The difference between them is this is a z-score and this is a t-score. So if you want to use the z-score one, you got to prove it. And if not, we're going to find out next class about the next one. Okay, and the bottom one is for proportions. And so when do I use proportions again? Categorical or qualitative data, right? So when you see the word mean, it's going to be one of the 2 mean formulas. So usually students have trouble with what formula do I use. So look for those, right? If it's a mean, it's not a proportion because they're oil and water, they don't mix. It's either mean or proportion. One's quantitative data, one's categorical or qualitative data. Okay, so I have to first decide, right, all of them are going to be the sample statistic plus and minus the margin of error. So which one do I use? Do I use the one with the z-score or the t-score? So I need a proof. What is my proof? Okay, so now I can use, and the formula says z alpha divided by 2. I want to write it exactly as it's written on the thing. And it gives you, puts the finite correction factor in it just in case you get to use it. Okay, I won't know which way I want to do. It's the sigma first. Do I get to use this in this question?
No.
Why not? Right, because big N's not given. But if you guys had put big N equals 260, you'd have gone down the wrong path of who done it. Because you'd have been using this, right? Because 36 is more than 5% of 260. So don't do that. Now if you do it on a test, you end up losing 2 points out of 20. It's not the end of the life, But that's what it's there for, to throw you. So you have to use the finite correction factor somewhere on your exam. And somewhere on your exam, you're going to be either given a number like we were in chapter 7, where we did the 2,500 managers, you take 30, and that 30 is not 5%, so you were not allowed to use it. Or a question like this, where there might be something that's trying to distract you, and some people will start using it when they shouldn't. Okay, so you've got to pay attention when you're writing all this stuff down. So once you've made that decision, this is a plug and chug question, right? This is fairly simple to fill in. X bar is 31,100. Okay, we'll come back to this z-score again in a minute. And then this is 4,500 over the square root of 36, right? The only thing that might give you a little issue is to find the z-score. Okay, but it says z alpha over 2, which in this question is z 0.05 divided by 2, which is 0.025. Agreed? So that's when you go to your booklet, you look for your 0.025, and it's negative 1.96. Exactly. It's exactly that. Okay. So we put in, we've already got the plus and minus here. We just put 1.96. Because we know the other side is the plus 1.96. Right? We got the negative 1.96 and the positive 1.96. Now you just do the calculations. Now, part A might say, what is the standard error? And what would you tell me? What is the standard error? What is it?
750.
750. This is the standard error, right? Do you agree? This is the standard error, 750. If you were asked, what is the margin of error? What would you tell me? Multiplied.
1,470.
It is the 750 times the 1.96. This is the margin of error. All of this is the margin of error. This is the standard error. This is the margin of error. So it's multiplied by the z-score. Standard error multiplied by the z-score. What's the confidence? What's the 95% confidence interval? It's this plus 1470, right? So and minus 1470. You agree? What do you think I should write here?
X bar. Or no.
Yes, good catch. I know what X bar is, right? This is X bar. What I'm trying to find is the interval in which I think the population mean falls. So what I would say is, okay, we're 95% confident that the population's mean annual income is between 29,630 and 32,570. So the town on average earns between 29,630 and 32,570. But it doesn't mean that Josh can't live there if he makes 100,000. Could be 70% of the population are unemployed, 30% of them make 100,000 each, and so therefore on average they make $30,000, which is in that interval. Now remember, I'm only 95% sure I'm right. That means there's a 5% chance I'm wrong. If I did this in 20 towns, 1 time out of 20 I'm going to be wrong. That's what 5% being wrong is, 1 out of 20. Okay? Who has a question about this? Okay, I want to practice looking up some z-scores. So let's say we've already proved that it's a z-score. What would be the z